You can't. It's over your head. I promise. Normally I do second period because it's class 2, but I can't do third and fourth period at all because people had to sit in every seat, and those people in the middle would be on. But you're not on, I promise. Alright. 1 through 6, a lot of people in fourth period gave me decimal answers on those. If you give a decimal answer on those on the test, it is wrong. The directions do not say approximate or round, they say simplify. So when it says simplify, it means if it's not a whole number, you got to keep it in radical terms. Okay? Alright, so numero uno, that's a pretty easy one. You can just type that in your calculator if you need to. Negative 32 to the 3/5 power. I did it using power over root. The 5th root of negative 32 is negative 2, and then negative 2 cubed is negative 8. So we'd have a big old negative 8 there. Alright, now number 2 is one that you're going to still have a radical in your answer. You can't just put a decimal on that. You got 2 square roots of 72 minus 3 square roots of 2. Since this is a subtraction problem, in order to add or subtract with radicals, it's got to be like terms. Square roots are the same, square root, but the stuff underneath them is not the same. 72 and 2 are not the same, so like they are, you can't subtract them. I can't break 2 down, so maybe if I could break 72 down to have a 2 in it, they can become like terms. 72 is the same as 36 times 2. And we did that earlier in the year a while ago. That's handy though because 36 is a perfect square. What's the square root of 36? 6. So we bring a 6 out there with that 2 and multiply those. That makes 12. Then we still got square root of 2. Drop down your minus 3 square root of 2. Now it's like terms. 12 of these minus 3 of those gets us 9 of those.
That's right.
Yo!
Can you pick up for a second?
Oh, Lord.
Did you say Lord?
Yep. I'm just saying a prayer. Yes, ma'am. I'll send them because I'm videoing this lesson, so. Alright, bye. Bailey, you need to go to the office. Just for a second, you got a parent that wants to tell you something. She was going to put you on that phone, but I was like, I'm videoing. That would be weird. Don't look back. Alright, number 3 is an easy one.
Is that going to be in your video?
Yep. But better than her like having a conversation with her mom. 5th root of, one day in first period when I was videoing, we were talking about possums. Well, you know, you get a little bit of everything when you watch the math videos. Ms. Stewart was telling me about when she had a possum in her ceiling, and every night it would come down in her room.
Oh my goodness.
Yeah.
Possums are one that are bald, right?
Possums are what?
Bald.
No, they got hair. They're ugly and got a real long tail and gray spear that sticks up.
They look like a big old rat.
Yeah. Alright, on this one, number 3, this is division, and we can divide on this because it's 5th root and 5th root. So my answer is going to be 5th root, and then I just divide 1,215 divided by 5. That got me 243. Now, if that'll break down, I'll break it down. Luckily, I don't even got to break it down. It's a perfect 5th. The 5th root of 243 is 3. 3 times 3 times 3 times 3 times 3 is 243. So number 3 would be 3. There's lots of 3's in that. Alright, on 4, it's probably the one I have the most questions on all day long. We ready? 4's got the cube roots of negative 8x cubed, y to the 5th, z to the 7th. Yes, son, you go back in?
Yes.
You got it. That's okay. It's okay. That's why smart boards are good. You can go back. Sometimes they don't work and they're bad.
Alright, we're good.
I just thought I was going to get great. Alright. Tricked me. Alright, so when you got a lot of stuff happening underneath there like we do, you're just going to break it down, go one thing at a time, left to right. So I'm going to take my negative 8, cube root of negative 8. 8 is a perfect cube, 2 times 2 times 2. So the cube root of negative 8 is negative 2. Negative 2 gets to come out and play. X cubed, the cube root of x cubed. Cubed and cubed cancel out. That's a perfect cube. So the x gets to come out and play. Now the dilemma comes in on this other stuff because these aren't cubes. So what I'm going to do is take that y to the fifth and I'm going to rewrite that using cubes. So y to the fifth would be the same as y cubed and y squared because 3 plus 2 is 5. Z to the seventh, if I use cubes on it, 3, 6, and then I got to have a 1 for a 7. Okay, so now the cube root of y cubed, that gets to come out and play as a y. So I'm going to bring a y down here with my other stuff. Y squared, it doesn't have a perfect cube. It's got to stay in. If the power is smaller than the root, it's always going to have to stay in. So 2 right here is smaller than 3. All right, on to these z's. Cube root of z cubed is z. But check it out, you got 2 of those. So when you bring out a z and a z, that makes it a z squared. And then that z will still have to stay in. So we got all this stuff outside. And then inside, we've got a y squared and a z. That's it. Okay, 5's a pretty simple one. We ready? Got it. All right. You can do 5 on your calculator, or you could do it using power over root. I'm going to use power over root a lot on this. Cube root of 27, because power over root, cube root of 27 is 3, and then 3 squared is 9. So you just get a 9 on number 5. All right, 6, we got 2 over 1 minus the square root of 2. Deal with this is, remember the rule, you can't leave a radical on bottom. So we can cancel out a radical on bottom several different ways, but this one's a binomial. When it's a binomial, the only way we can cancel it out is to multiply by the conjugate. Remember, the conjugate's just the opposite sign. So we're going to multiply top and bottom by 1 plus the square root of 2. On the top, it's easy. You just distribute the 2. 2 times 1 is 2. 2 times the square root of 2 is not square root of 4. Somebody this morning told me that. This 2 is not underneath the square root, so it just stays 2 square root of 2. And on the bottom, when I multiply these dudes, it's FOIL. And a lot of people yesterday say, oh, they just cancel out. Well, not exactly. The radicals cancel out, but you still might have other stuff down there, so you got to do your FOIL still. So on your third, go ahead.
Would you give me a D?
Where to get what? This?
Yes.
I distributed 2 to 1, and 2 times 1, and 2 times the square root of 2. Alright, so my FOIL on the bottom, I got first is a 1. Outer, I got positive 1 square root of 2. Inner, I got negative 1 square root of 2. Last, these are both square roots. Square root of 2 and square root of 2, I got negative square root of 4. Okay, now we talk about the radicals canceling out, but it looks like I got 3 of them down there. No, not really. Right here, square root of 2 minus square root of 2, he gone. And this, square root of 4 is 2, so I'm just left with 1 minus 2, which is negative 1. So my denominator is negative 1. Some people left their answer there. That's okay if you left your answer there. I did not. I went ahead and divided everything by negative 1. I just changed my signs. So that's what I wrote as my answer. But if you left it here over the negative 1, it's still correct. I'd count that right. Alright, 7, 8, 9, 10, all you're describing the transformation, similar to what we did on the bell ringer. The dilemma that I heard all day was people didn't know what the original one looked like. They give you the equation for it. So when I was working this, I took the equation they gave me, plugged it in my graphing calculator, then I compared my graphing calculator to the test paper. That's what you would need to be doing on that. Okay, so are we ready? On number 7, I'm looking at the square root of x. My graphing calculator, I get something that just looks similar to that. Starts at the origin, curves a little bit, goes to the right. The one they give me on the test looks like that, except it's scooted over there to negative 3, right? It says that point was negative 3, 0. So if I went from 0, 0 to negative 3, 0, I moved left 3 units. see, does it tell me what to name this? G. So I'm going to say G of X. When I go left and right, does that go in with the X or out on the end? In with the X, and it's always the opposite way, so that's going to be plus 3, all underneath the radical.
Why would it be in it?
Because it's left and right, that's just the rule. It always goes in with the X. If it's up and down, it's when it's stuck out on the end. The one on the bell ringer was up and down, we stuck it out on the end. All right, ready? Come on. All right, on 8, the cube root of X, if you graph that on your calculator, get something looking similar to that. The one they gave me, it still goes through the origin right there, but it pulled it way up and way down. So it took my black one, grabbed a hold of both sides of it, and stretched it. So it's a stretch. When it's a stretch, it multiplies by something out in front. So I'm going to have the cube root of X, but I'm going to have a number out here in front that I got to multiply it by. Okay, good news, they gave you here on this one, they gave you a point at 1,4, and the one on my calculator had a point at 1,1. So what do I multiply 1 by to make it become a 4? So I'll just stick a 4 over here in front of that. Alright, number 9's a pretty simple one. That starts off with the 5th root of X. Now look at, we ready? Look at the 5th root of X. It's going to look something, just got a bigger bend in it, bigger bend in it. But then the one on my paper is like that. It scooted it up. So it was here at 0, 0, and then when my paper says that's 0, 1, it scooted it up 1. So G of X is the 5th root of X, up and down, goes out on the end, not inside. Now when we get to 10 here, just a smidgen second, 10 was the one that made me think the most because it has 2 things happening on it. I'm going to figure out 2 different things on it. You ready? Okay, no problem. So I might keep that. Alright, 10 has got the square root of X. We looked at that one, number 7. So let me draw the square root of X again real quick. Pretty simple there. But 10 drops it down to 0, -2. And then its curve is also way different. Pulled that curve up, stretched it out, didn't it? So it's going to have a scoop down. So I got the square root of X, scoop down of 2, but it's also stretching it out. Now I had a difficult time originally figuring out how much it stretched that thing. The good news is it gave me a point on that graph of 1, 1. So it means I got to plug a 1 in for the X and get a 1 out for the Y, input output. So if I plug a 1 in just like this is, square root of 1 minus 2, square root of 1 is 1 and 1 minus 2 is -1. Well, I need it to be 1, so that doesn't work. What if I put a 2 here? Okay, and the reason I can do trial and error on this, by the way, is because there's never any stretches of outlandish numbers. Like you don't have 543 times the square root of X. You don't have to guess crazy numbers. Our stretches are usually 2, 3, or 4. You know, they're small deals, so we can do some trial and error. All right, I'll plug a 1 in here. Square root of 1 is 1. 2 times 1 is 2. 2 minus 2 is 0. I need a 1, so that didn't work. But look, I went from a -1 to a 0, so I'm getting closer. Let's try 3. Square root of 1 is 1. 3 times 1 is 3. What's 3 minus 2? Winner, winner, chicken dinner. So that got me that 0.11. So throw my g of x on that. That's your answer. Flush it. So first thing I had to realize was the easy part, that it was down 2. After that, it wasn't too difficult to figure out. When we get to 11, that's just a plug them in the calculator problem, so it's an easy one everybody likes. But it's got 4 answers, so make sure that you got something like that on your test where you're able to get all 4 points. Gives you the equation t is equal to 2.31 times L to the 1/2 power. Now, people all day say, I don't understand that formula. You don't have to understand the formula. You just got to plug the numbers in for L that they gave you. Okay, it says that Act 1, the length was 60 feet. Act 2, it was 40 feet. Act 3, it was 100 feet. I'm just reading that off the table they gave me. Act 4, it's 300 feet. It tells me to plug those in, get an answer, and round it to the nearest tenth. So this first one would look like 2.31 times 60 to the 1/2 power. I plug that in my calculator. I round it to the nearest tenth. I got 17.9. I'm going to do the same for 40. 2.31 times 40 to the 1/2 power. Plug that in my calculator. I round it to the nearest tenth. I got 14.6. And the 100, 2.31 times 100. I actually could do that one in my head, because the square root, half power means square root. Square root of 100 is 10. 10 times 2.31 is 23.1. And then the last one, I got irritated at the last one. When you plug that in your calculator, you get like 40.01 something or another. It says round to the nearest tenth. Well, that would round that to 40.0. And I normally don't write that. I normally just write 40. But it said nearest tenth, so I put that tenth on there, even though it doesn't have a value. Okay, now when we get to 12 and 13, there's some of the stuff that we've done most recently, the function operations. We did function operations and inverses. I think we did that Tuesday. So it's some of the more recent stuff. But 12 and 13 both have 6 answers, so there's 6 points. It's big point time on 12 and 13. Are we ready? Well, I'm into. Alright, on 12, f of x is negative 2x to the 2/5, and g of x is negative x to the 2/5. Alright, so here's reading the problem, the 6 things they asked for. F plus g of x, there's going to be answer number 1. F minus g of x, there's going to be answer number 2. The domain of each, so there's answer number 3 and answer number 4. Then it wants us to evaluate for 243 on each, so there's going to be our 5 and 6. Alright, when we add and subtract these things, we can only add and subtract if they're like terms, and to be like terms, their powers have to be exactly the same. They are here. You got x to the 2/5 and x to the 2/5, so you got like terms. So for this one, f plus g, you just add your coefficients. Negative 2 plus negative 1 is negative 3. Powers, let me rewrite that, that's ugly. Powers don't change when you add and subtract, so it's going to stay 2/5. Negative 3x to the 2/5. Okay, now down here I subtract them. Negative 2 minus negative 1. That's negative 1. And then my powers stay the same. So there's answers 1 and 2. Alright, domain. I kind of just pushed y'all off a little bit on domain so we can clear it all up today. It's easy. Over there on the dry erase board above David, I've got only 2 options that you're going to have for domain on these. Okay, our domain could be all real numbers. This is a symbol for all real numbers. Remember the capital R with 2 legs. Y'all taught me that. My domain could be all real numbers, or my domain could be greater than or equal to 0. Okay, so I got a 50-50 chance now that I know that. Just got to guess the right one. Is it all real numbers, or is it greater than or equal to 0? That's based on your roots. Okay, think about a square root. What happens if we have the square root of a negative number? What's the square root of a negative number? What's it got in it? Come on, knotheads. What's the square root of a negative number? Nope. Nope. What's the square root of negative 4? Say that again. It's 2i. It's got an I in it. So we can't have a real number if it's a negative with a square root. What about a 4th root? Same thing. What about a 6th root? Same thing. So if our root is even, 2nd root, 4th root, 6th root, it can't be negative. And you're not negative if you're bigger than 0. Now, can I have a cube root of an odd number? Yes, we did on number 4. The cube root of negative 8 was negative 2. So if it's an odd root, cube root, 5th root, 7th root, it can be anything, positive or negative. That's why you got all real numbers. So what we got to figure out on these highlighted answers is my root odd or even. Okay, your root comes off of your exponent. Is the 2 or the 5 the root? Power over root.
2.
Power over root. Power over root. So that 2 is the power, that 5 is the root, right? So I got an odd number for my root, which means my domain on both of those is all real numbers. Pretty simple. And I told all of the class, I would make sure I wrote this stuff here somewhere, so you'll know. Because it was easy after that common sense there. Alright, so we got 4 of our 6. The last 2 answers, you just get on your calculator by plugging the 243 in. So you'll do negative 3 times 243 to the 2/5 power. That got me negative 27. And then I did negative 243 to the 2/5 power. That got me negative 9. So y'all better be able to do those on your calculator. Yes, ma'am. Now, when we flip the page over here in just a second, when you get that one done, the next question is the same, except instead of add, subtract, it's multiply, divide. You still got to get the same 6 things, but instead of adding and subtracting, we're multiplying and dividing. You do not have to be like terms to multiply and divide. Okay? Are we ready? We on page 2? Alright, page 2, I've got f of x is equal to 2/3 x to the 3/2, and g of x is equal to negative 4x. Now these are not like terms because this one's a 3/2 and this one's a 1, but I told you, I reminded you on division and multiplication, they don't have to be like terms. Okay, so number 1 answer wants us to do f times g of x. People in the morning said that's not the same as our notes. Well, our notes, I just didn't put the times sign. F times G, and F right next to a G means the same thing. And then we're going to do F divided by G of X. And we're going to tell the domain of each, which we now know we got a 50-50 shot at. And then we're going to evaluate this one for 4. Plug 4s into our answers. Alright, so on the F times G of X, I want to take 2/3 x to the 3/2. I'm going to multiply it by negative 4x. Okay, so what we start with is our coefficients. We're going to do 2/3 times -4. 2/3 times -4, that gets me -8/3. It's a negative there. Can you tell that's a negative? Do I need to work on that? You good? Okay, then I got an x. What do you do with your powers when it's multiplied? Add. Very good. So 3/2 plus 1, because this is an understood 1 on this x. 3/2 plus 1 is 5/2. Now, I have people want to write that as, instead of 5/2, they want to put 2.5, because that's the same. That's not wrong, but if this stuff is in terms of power over root, you don't have power over root if you got a mixed number. So leave it as an improper fraction. Multiply the coefficients. 2/3 times -4, that's -8/3. And then on multiplication, you add powers. 3/2 plus 1 is 5/2. You alright? Alright, on the division one now. Gonna have, scoot this up here a little bit, we're gonna have 2/3 x to the 3/2 divided by -4x. So same thing, except we're just dividing. 2/3 divided by -4, that got me -1/6. Now what do you do with powers when it's division? Subtract them, good. So I got 3/2 minus 1, which is 1/2. So there's our second answer. I did 2/3 divided by -4. No, just the fraction itself. Alright, so now in our domain, we're looking at, is it all real numbers, or is it x is going to be greater than or equal to 0? What's the root, the 5 or the 2? 2. 2 is an even number, which means its domain is x is going to be greater than or equal to 0. What's my root here on this one? 2, so same thing. X is greater than or equal to 0. So we've got 4, 2 left to go. Last two, all you got to do is use your calculator to get those. You're plugging a 4 in this time. So I've got -8/3 times 4 to the 5/2. I got a crazy fraction on that one. -256 over 3. If you wrote that as a mixed number, that's okay. It'd be like 8 and something. When I plug the 4 in, -1/6 times 4 to the 1/2, I got -1/3. So there's your 6 answers there. Now, while we're getting ready to go to 14, there are actually a ton of answers that you can have on number 14. I'm just going to show you how to get the most basic ones that I came up with. But you could write, you're writing an equation that satisfies those conditions. You could come up with lots of different equations to satisfy them. It doesn't have to be the one I'm going to use, but I'll show you the most basic ones. Alright, it says, write two functions whose graphs are translations. That means just a slide of y equals the square root of x. So there's our y equals the square root of x. It says the first function has got to have a domain of x is greater than or equal to -3. Domain is the x's, -3 would be over here. So greater than that means it's got to be to the right of it. So I could take this graph and where could I scoot it so that everything is still on the right of it? Well, I could scoot it anywhere to the right and everything would still be on the right. True. The farthest left I could scoot it would be to that point. So I just said y's got to be square root of x, and I scooted it left, so left goes in with the x plus 3. Yes, sir. Okay, then it asks for 2. We've got another one to write on number 14. It says the second function's got to have a range, y is less than or equal to 3. Range is up and down y's, so 3 could be here. Less than or equal to that means it's got to stay below it. So I got to take this original function that I have here and make sure that I stay below it. Now there's a math term that we haven't used yet this year, but we will. It's a graphing term for when your graph gets closer and closer and closer and keeps approaching something but never touches it. It's called an asymptote. We'll talk about asymptotes a little bit longer. These graphs, these square root of x graphs, they look like they keep inching up, but they actually have asymptotes. They're going to get infinitely closer to something that you're going to need a NASA microscope to see, but they're never going to touch it. So all I need to do to make sure this thing doesn't ever cross 3 is just scoot it down some. So you pick how much you want to scoot it down. I just scooted it down since we were talking about 3's. I scooted it down 3. So I said y is equal to the square root of x. And I'm just going to scoot you down so the minus 3 does not go inside. Now, like I said, there's lots of different equations that would have satisfied those. I just tried to come up with some basic no-brainers. Alrighty, 15 will be an easy one. We just got to plug some numbers in. Now, work a little bit backwards with it, but we can do it. We ready? We're doing good. We're going to finish, but we got to keep moving. Good.
Dang, any kind of kill phone.
Alright, it says that the distance is equal to, hey, Blake, be quiet, 1.35 times the height to the 1/2 power. Somehow, how far you can see over the horizon is based on how tall you are. Distance is how far you can see, and the h is how tall you are. So it says a person can see 2.75 miles. How tall are they? So we plug 2.75 in for the distance, and we got to solve for height. So first thing I need to do is get rid of this 1/2 power. How do you undo a 1/2 power? Good, the reciprocal. So reciprocal 1/2 is 2 over 1. So we're going to square everything. So I'll just square this 2.75. That got me 7.5625. And like David said, when I square this 1/2, that's 1. So it just cancels out. So it's equal to 1.35h. Now I'm trying to solve for h, so I divide by 1.35. And it tells me on this one to round to the nearest hundredth. That rounded to 5.60 feet. I normally, if I'm dealing with feet or something, how tall somebody is, I normally like to write it in terms of feet and inches. Like 5 feet 7 inches, 5 feet 4 inches, but it told me to round 100, so I kept it at 5.60. That wasn't too bad. Now 16 is easy, but it's got a trick to it. We ready? Yep. Alright. They gave me the exact same problem, except one of them on 16's got an inequality and one of them's got an equal sign. So I'm going to write them both up here. Oh, it's a -2 if I wrote the problem right. When y'all ask where y'all messed up, that's one of the first things I check for is did you write the problem right? Okay, we got one with an inequality. Then I'm going to write it again with the equal sign that it has. So it says to describe the similarities and the differences on how we do this. I'm going to show the similarities by showing my work. I'm going to work both of those problems at the same time going down, and you're going to see I do the exact same thing on both sides of it. So right here it's got 4 being added, so I'm going to subtract 4. Same thing over here. Subtract 4. I'm doing the same thing. So this will be 6 square root of x minus 2. It's less than or equal to 24. This will be 6 square root of x minus 2. is equal to 24. So I did the exact same thing so far. Now it's being multiplied by 6, so I'm going to divide everything by 6 on both sides. So I got the square root of x minus 2 is less than or equal to 4. And over here, the square root of x minus 2 is equal to 4. Now they're being square rooted, so I'm going to square everything on both sides. So the square and the square root cancel out, so x minus 2 is less than or equal to 16, because 4 squared. Here the square cancel out, so x minus 2 is equal to 16. And our last step is I've got 2 being subtracted, so I'm adding 2 to everything. So here I got x is less than or equal to 18, and here I got x is equal to 18. So I just showed my similarities, because I did the exact same thing to every step of those. But there's a difference that I've not yet showed you that we got to figure out. It doesn't have anything to do with this one over here because it says x equals 18. So that's just plain cut and dry as it can be, x is equal to 18. But this thing says, if I put this in plain old dumb co-trite terms, x has got to be smaller than 18. It can be any number, 18 or smaller. It could be negative 99. It could be 7, as long as it's 18 or smaller, right? But go back up and look at your original problem. Right up here where my mouse is hovering. What if I plugged a 1 in for that x? What's 1 minus 2?
1.
No.
Negative 1.
Negative 1. Can I have the square root of a negative 1? No. Well, this told me anything less than 18 would work, and I just found out that 1 didn't work. Okay, well, what if I plugged a 2 in? What's 2 minus 2?
0.
0. Can you have square root of 0?
No.
Yeah, square root of 0 is 0. So if I'm 2, I'm okay, but if I'm 1, I'm not any good. So while x has got to be less than or equal to 18, it's also got to be greater than or equal to 2. So that's the difference. And the reason it's got to be greater than or equal to 2 is because I can't square root a negative. Now we know from past lessons that it has an I in it, but we're talking about real numbers here, not imaginary numbers. Whoop, whoop. Alright, we got one more, A and a B, and it's an easy one. It's involving inverse. And that again is the most recent thing that we looked at on Tuesday, finding inverses. Hey, I can't believe you can't read that. That's as plain as can be. Come on. Jeez. Acting like my writing's messy. Thanks, David. Why don't you tell me what you really think? Alright, we got it? Ready? Okay. Gives me, talking about producing tennis rackets here on 17, tells me that the number of months is equal to how many tennis rackets I produced to the third power divided by 90. It says to find the inverse of that. Step 1 in finding the inverse, we said, was to switch the variables. So I'm going to say P equals M cubed divided by 90. I started to spell 90, I guess. I wrote it in. Divided by 90. Now, step 2 we wrote in our notes was solve for y. Well, this one don't have y's. It's got m's and p's. So my y is like my m, so I'm going to solve for that. It's being divided by 90. How do you undo division of 90? Multiply, so 90 times p is equal to m cubed. How do I undo a cubed? Cube root. So m is the cube root of 90 times p. And there you go. There's your inverse. Okay, now part B says, how many tennis rackets will be produced in 20 months? Round your answer to the nearest whole racket. So I got to plug a 20 in for my months. Do I do that on my original equation or my inverse? Nope, original. Because original is talking about the number of months you're producing rackets. So I'm going to say 20 months, 20 equals P cubed over 90. Now my steps for solving this are going to be like my inverse steps. It's being divided by 90, so I'll multiply by 90. 90 times 20 is 1800. Undo the cube by cube rooting, and I did that on my calculator, and I got 12.164. Now, I almost missed this question. I almost put 12, because it said round to the nearest whole tennis racket, right? But if I would have put 12, I'd have been wrong. And the reason I had to go back and underline it so I'd remember to tell y'all, look up there in the original problem. It says to produce P tennis rackets, and then in parentheses it says in thousands. So now I got to take my number here and convert that to thousands. So I got to multiply that by 1,000, which means move your decimal point 3 times. I almost missed that. Sneaky people are not nice. Like some of y'all, shifty. Alright, you feel better about it than you did yesterday? Yes, no, maybe?
No.
No?
Yeah.
Yes, thank you, Jasmine. Yes. You got it there yet? Good, 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 good. Alright, that'll be it in a nutshell.